So I gotta erase a few things here. Clear objects. Okay, so let's do the first one. X less or equal to -3, so let's graph that. So we're gonna go to -3 on the x-axis, and this is a, let me write this. This is gonna be a solid line, this is gonna be a solid line, because the points on that line is included in our solution. So let's first of all put that line there. Oops, solid. Okay, there's my solid line. Now, now we have to figure out if this line here, if you're going to shade to the left, we're going to shade this way, or we're going to shade that way. We got to figure that out. So our inequality is x less or equal to -3. Let's pick a point 0, 0. Let's do it. That's my test point. This is my x and this is my y. So I'm going to replace x. I don't have to worry about the y. So I can replace x. It says 0 is less or equal to -3. And that's not true. 0 is not less, but it's greater. So 0, 0 is here. So I don't want this side here. So it's telling me that you want this side. And if you want to confirm, pick a point on this side of the world, on the left side of the blue line. So let's pick this point here, which is -5 and 2. So if I pick the point -5 and 2, and I take that inequality again, x is less or equal to -3, and I replace the x value with 5, I get -5 is less or equal to -3, and you see that's true. So it doesn't matter, any point you pick on this side will make the first inequality true. So we're good there. The second inequality, we got to rewrite it. So we get 5x plus 3y, let me change the color to red, greater or equal to -9. We're going to subtract 5x from both sides, and we get 3y greater or equal to -5x minus 9. We're going to divide everybody by 3, and we get y is greater or equal to -5 over 3x, and then -9 divided by 3 is -3. Ready to graph? Yeah. So my y-intercept is -3 right here. So my slope is -5 over 3. So up and down we count 5, and left and right we count 3. So 1, 2, 3, 1, 2, 3, 4, 5, and then we go 3 to the left because it's a negative slope. So we have 2 points. We're going to use a solid line, which I'm going to change colors. Solid line. There we go. And now again, we got to do a test point, right? So let's pick 0, 0. Let's replace the x and the y. So we get 0 greater than -5 over 3 times 0 minus 3, which is the same thing as 0 is greater than or equal to -3, which is a true statement. So because this point 0, 0 worked, right, it means that every point on to the right of this line will always also work. So every single point here. And if you want to shade it, you can shade it. I'm just doing this. Now there's going to be a section. Let me just do this properly here. It's going to be a section. And you'll see it right now. Right where the blue and the red meet, which is this section over here. And you can put an S here. So any point in that section will make this inequality true. So let's take a point there. So I'm going to pick -4 and -5. So -4 and +5, which is right here. -4 and right here. I want to change it to pink. This point right here, which is in that solution area, right? And I'm going to check. So the first inequality is x less or equal to -3. I'm going to replace the x with -4. Is that a true statement? Yes, it is. The second inequality, 5x plus 3y greater than -9. Replace x and y. I get 5 times -4 plus 3 times 5. That's supposed to be greater than -9. You get -20. -20 plus 15 greater than -9, and we get -5 is greater than -9. Is that true? Yes, it is. So we know we did this correctly. Second one, we gotta rewrite both of them. Right, so let's take the first one, 4x minus 3y less than 9 minus 4x minus 4x. -3y less or equal to -4x plus 9. We're going to divide this by negative 3, negative 3, and negative 3. Because we're dividing by a negative number, we're going to change the inequality sign to make it the other way, greater. Negative 4 divided by negative 3 is just 4 over 3x. And then 9 divided by negative 3 is negative 3. So there. So my y-intercept is negative 3. Let me graph that. We're going to go up 4 and then 3 to the right. 1, 2, 3, 4, and 3 to the right. Why do I go right? Because when I connect these 2 points, my slope needs to be positive. And this is a dashed line, right? Points on the line do not count, right? It doesn't make the inequality true, so that's what that's showing. And give it a name. There we go. Now, get the point 0, 0, plug it in. Point 0, 0, plug it in, see what happens. 0 is greater than 4 over 3 times 0 minus negative 3. 0 is greater than negative 3. Is 0 greater than negative 3? Yes, it is. And 0 is above the red line, so 0, 0 is above the line. So that means that every point here will also make the inequality true. And if you don't believe it, just pick points above this red line, any point, and keep trying and see, and you'll notice that every single one of them works. Let me erase this. The second inequality. X plus 3y is greater than 6. We're going to subtract x from both sides. 3y is greater than negative x plus 6. Divide by 3, divide by 3, divide by 3. We're dividing by a positive number, so we don't have to worry about switching the signs. So 3 divided by 3 is just 1. We get y greater than, and I'm going to put the 1 there, negative 1/3 x plus 2, because 6 divided by 3 is 2. My y-intercept is 2, it's right here. It's negative 1/3, so we know the slope is going to go down like this, right? So it's up and down is 1, left and right is 3, so 1 up, 3 to the left. 1 up, 1, 2, 3, there. If I go the other way, I go 1 down and 3 to the right. So as long as when I connect the dots, right, like points, it's a slope that goes down, we're good. Oops, let me change colors. There. Right, points on the line do not make the inequality true. Now, take a test point. Either it's going to be points above the blue or below the blue line. So, use 0, 0. That's going to tell us which way to shade. So we're going to get 0 greater than negative 1/3 times 0 plus 2. And we get 0 is greater than 2. 0 is not greater than 2. So 0, 0 is below the blue line. So we don't want that area, any number below the blue line. So we want numbers above. So notice this whole section where the purple and the blue meet. That's our solution. Here's our solution. So pick a point in here, any point in here, and plug it in both inequalities and see if it works. Let's pick an easy point. Okay, I'm going to pick 2 and 2. Pick the point. You could have picked something on the y-axis, right? 0 and 3, 0 and 4. I picked 2 and 2. So we get 4 times 2 minus 3 times 2 less than 9. 4 times 2 is 8. 3 times 2 is 6. And you'll notice that that is indeed less than 9. So the first inequality is true. The second one, 2 plus 3 times 2 is greater than 6. 2 plus 6 is greater than 6. 8 is greater than 6. So this point right here that I picked, 2 and 2, it worked for equation 1. I'm sorry, inequality 1. And it worked for inequality 2. Right? I hope you like doing these. Right? They're fun. Yeah, I know. A very geeky way, I guess. All right, the first one again. That's one that's easy. X plus, let me just move it over here. X plus y greater than 2 minus x minus x. So we get y is greater than negative x plus 2. I'll put a 1 here. Makes my life easier. Over 1. So my y-intercept is 2. Is a negative slope. Right, up and down we're gonna go 1, and left and right we're gonna go 1. So this one's easy. Look, this one we can actually get so many points. You don't need them, but they're there. And it's going to be a dashed line because the sign does not have an equal sign under it. So dashed line. All right, let's move that line a little bit. There you go. Give it a name. Hopefully I've been giving lines names. So this one is y greater than negative x plus 2. Now, do we shade above or below it? Get the test point 0, 0. So we place x with 0 and y with 0, and we get 0 is greater than 2, which is not true. So I don't want, this point didn't work, so I don't want this side. This side does not work for me. So I'm going to shade above it. Right? So every point that's not on the line and above it is a solution to this inequality. Second inequality. Two x, let me change colors, 2x minus y greater than 1. So we're going to minus 2x on both sides, and we get negative y greater than negative 2x plus 1. We're going to divide by negative 1, divide by negative 1, divide by negative 1, right? So because we divided by a negative coefficient here, the negative coefficient was negative 1, so we're going to, this becomes positive, but the sign changes to the other side. Negative 2 divided by negative 1 is just 2 over 1x. And then 1 divided by negative 1 is just negative 1. So there. So for this one, my y-intercept is negative 1, which is right here. My slope is positive, it's 2 over 1. So I'm going to count 2 up and 1 to the right. 2 up and 1 to the right. 2 up and 1 to the right. So enough points. And this is, again, a dashed line. Okay, it's going to be a dashed line. And this is y less than 2 over 1x minus 1. So now I get to figure out if I want points above to the left, right, on this side, or on this side. That's what I... So pick 0, 0. I can. Look, it's right there above it. Let me replace y and x with 0. So y is 0. 2 times 0, less than 1. 0 is less than negative 1. Is 0 less than negative 1? It is not. So points above the line, the red line, are not going to work. So instead, I'm going to, what do you call, shade this way. Sorry, it should be more perpendicular. But I can't. So you'll notice the point of intersection, right, where the blue and the red meet. So my solution is this whole area here. Okay, that's my solution. Let's pick a point there. Let's pick an easy point. I'm going to pick the point, I don't know, 3, 2. This point right here, 3, 2. I'm going to try 3, 2. Point 3, 2, which is in the shaded area of blue and red. And I'm going to replace it in both inequalities. The first one I get 3 plus 2 greater than 2, and that indeed is true. And the second one I get 2 times 3 minus 2 greater than 1. 6 minus 2 greater than 1, I get 4 greater than 1, which is also true. So we know that we did this correctly. 8. X plus y is greater or equal to 2, so let's change that. Minus x, y is greater or equal to negative x plus 2. And I'm going to put a 1 over 1 because that helps me with the slope, right? So y-intercept is 2, right here. We're going to go, and the slope is negative, so we know it's going to go down like this. So 1 up, 1 to the left, 1 up, 1 to the left, or 1 to the right, 1 down, and 1 to the right, whichever way. Right, so this one, again, and this one is going to be a solid line, right? It's going to be a solid line. Ah, shoot. Get black. Solid line. There we go. So now I gotta, let me pick the point 0, 0, see if it works or not. So I get 0 greater or equal to negative 1 times 0 plus 2, and then I eventually get 0 is greater than 2. Is that true? It's not. So point 0, 0 failed, which means every point under the black line is gonna fail. So it's points above the line that's gonna, above the line, including points on the line, that will make my first inequality true. 2, oh, I forgot to, I keep forgetting to give names. So this is, I forget, what was it? Y greater or equal to negative x plus 2. So that's the name of the line. Second one. 4x plus y greater or equal to -1. So minus 4x minus 4x. So we get y greater or equal to -4x minus 1. So this is going to be a negative slope, and the y-intercept is -1 right here. So let me put the 4 over 1. So up and down you count 4, left and right you count 1. So 1, 2, 3, 1, 2, 2, 3, 4, and then 1 to the right. 1, 2, 3, 4, and 1 to the left. There, enough points. And this is going to be a solid line. There, which I'm going to change to red. If you have the luxury of using colors, please do so. I think it helps. Okay, now we need to see if we're going to shade up to the right of the red line or to the left. Let's pick the point 0, 0. We get 0 greater than -4 times 0 minus 1, and that's simply 0 is greater than -1, which is true. So where's 0, 0? To the left or right of the my red line is to the right. So this is the solution to the second inequality. Notice that the solution to both inequalities is this area over here where both the red and black line exists. So that's my solution. And any point there will work. So pick the easiest point you can think of. I mean, easiest, right? You know. And let's pick, I don't know, let's pick 0 and 4. Let's pick this number here as my solution. So let's try the point 0, comma 4. For the first inequality, I get 0 plus 4 greater or equal to 2, and that's obviously true. For the second inequality, I get 4 times 0 plus 4 greater or equal to whatever that number is, -1. So 4 times 0 is 0, and we get 4 greater or equal to -1, which is true. So that point worked, and we're good. A little bit of fun, maybe. Not so much, I don't know. All right, so that's that. We have more? Oh, yes, we do. Ugh. Whose idea was this? Okay. First one, let's again rewrite it. We get 4x plus 3y greater than -6 minus 4x minus 4x. The one thing is good about you'll definitely not have problem solving equations and inequalities because we've been solving so many. So 3y greater than -4x minus 6. We're going to divide everybody by 3. And we get y greater than -4 over 3x minus 2. Let's graph that. -2 is my y-intercept. It's a downward slope. It's a negative slope. So 1, 2, 3, 4, and then 1, 2, 3. We only need 2 points, and this is a dashed line. Okay, the first one's going to be a dashed line. Come on. It's going to be a dashed line. There we go. All right. Arrow, arrow, name. And let's try the test point 0, 0. So if I plug in 0, 0, if it works, we shade up above the line. If it doesn't, we shade under. So we get 0 greater than, that's going to be 0, right? -2. And 0 is greater than -2. Is that true? Yes, it is. So every single point above that line, not including the points on the line, will make the first inequality true. Right. Second inequality, change colors. X minus 3y less or equals to -9. Minus x on both sides. Minus 3y less or equal to -x minus 9. Divide by -3, divide by -3, divide by -3. Because we divided by a negative number, I'm going to flip the inequality the other way. So we get y is greater or equal to 1 over 3x, right? Plus 3. Y-intercept is 3, positive 3. It's a positive slope, so we need one more point. So up and down we go 1, left and right goes 3. So up 1, right 3, or down 1 and left 3. Doesn't matter which way you go. Now this is the second one is a solid line. Okay, a solid line. There. Now you need to figure out if we want to shade above the blue line or below the blue line. So let's pick the point 0, 0. We get 0 greater or equal than 1/3 times 0 plus 3, or just 0 is greater than 3. Is 0 greater than 3? No, it's not. So we don't want to shade below the blue, we want to shade above. And that area, I'm pretty sure everybody can see, this is your solution. Pick a point. Let's pick the point 0 and 5 right here. Right? Let's pick the point 0 and 5, and let's try for both. Right, so in the first inequality, right, we get 4 times 0 plus 3 times 5 is greater than -6. And we get 15 greater than -6, which is true. The second inequality, we get 0 minus 3 times 5 less or equal to -9. Well, 3 times 5 is -15, and -15 is definitely less than -9. So also makes the second inequality true. So that is good work. Third one. Okay, now I'm hungry. I need to eat something. Or just drink. All right. Y less than -2. Let's find that. Let's graph that. -2 is here. And it's going to be, this one means it's a dashed line. Right, so here's my dashed line. Now you just got to figure out it's going to be above that line or under, right? We shade up. So let me just, and this is y less than -2. So if you pick the point 0, 0 and you plug it in, well, you don't have to worry about plugging in x. We plug in 0 for y. We get 0 less than -2. Is 0 less than -2? It is not. So where do we want to shade? We want to shade this way. So points, any point under the blue line, not including points on the blue line, will make that inequality true. Second one, x plus y is greater than 1, greater or equal to 1. So x plus y greater than or equal to 1 minus x, y greater or equal to -x plus 1. And there's, the only thing I'm going to add is 1 over 1 here. Makes it easier for me to deal with this slope. Y-intercept, 1 right here. Slope, negative, so it's going to be coming down from left to right. So points, here are my points. 1 down, 1 right, or 1 up and 1 left. It's a dashed line. Here's my dashed line. So it's a dashed line. And now I just need to know if it's going to be above the red or below the red line. And let's pick the point 0, 0, substitute. So I get 0 greater than, obviously 0 plus 1. Is 0 greater than 1? No, it's not. So I don't want points, I don't want, what do you call, shade below the red line. I want shade above it, here, above the red line. And notice, where is our solution? The solution is right here. We can clearly see it where those two colors meet. There's my solution. Pick a point there, and we're going to, right, I keep forgetting. I know I tell you guys to do that all the time. I keep forgetting to label it. So this is y greater or equal to -x plus 1. That's the one. So now we got to do our test. Well, let's pick a point. 5 and -3. So let's use the point 5, comma, -3. And let's see if it works for both inequalities. So take the original, the first one. Y is less than -2. We're going to substitute y with -3. Look at that. That's true. The second inequality, x plus y is greater than 1. So x is 5 plus y, which is -3, is greater than 1. Is that true? And that's true again. So we know we did this correctly. 11. Clear objects. 11. So first inequality, 3x plus y greater or equal to -3 minus 3x minus 3x. We get y is greater or equal to -3x minus 3. Yeah, that's it. There's no, okay. So y-intercept, oh, sorry, I forgot to put it over 1. Y-intercept is -3. We're going to go up and down 3 and left and right 1. So 1, 2, 3. And we got to go left because it's a negative slope, right? So 1, 2, 3, 1 left. When we connect the dots, the corner points, it's going to be a solid line, which I'm going to keep the blue, solid line. And now you got to decide to shade either above or below. So let's do the test point 0, 0, right? The easiest of them. If you don't like 0, 0, pick 1 and 1, 2, whatever. Pick another point. So we get 0 greater than -3. Is that true? Yes, it is. So we want to go this way. We want to go on the same side of 0, 0 because 0, 0 worked. Our second inequality, let me erase this, is x plus 2y less or equal to 4. Minus x, we get 2y less or equal to -x plus 4. We're going to divide everybody by 2, a positive 2 by the way. And we get y is less or equal than -1 over 2x plus 2, because 4 divided by 2 is just 2. Y-intercept is 2, so it's right here. It's a negative slope. So we're going to go up and down, we go 1, left and right we go 2, changing y is 1, changing x is 2. So 1 up, 2 left. 1 up, 2 left. Okay, so let me grab, and we're going to grab this. So again, it's a negative slope, and it's a solid line. Let me give this guy a name. Y equals less or equal to -1 over 2x plus 2. So now pick the point 0, 0, right? See if we're going to shade above the red or below the red. So we get 0 less or equal to 2. Is 0 less or equal to 2? It is. So 0, 0 worked. So that means I want to shade this section here because that's a section where 0, 0 is below that line. Where's our solution? This one is nice and big. It's right here. That's my solution. For our check, we can also use 0, 0. Right? Because 0, 0 is right here. It's the point that is in the solution area. So makes life so much easier when I can pick 0, 0. So we get 3 times 0 plus 0 greater than -3, and that's obviously true. Second inequality, 0 plus 2 times 0 is less than 4. Also, obviously true. So we are good. X plus y greater or equal to -3. So again, x plus y greater or equal to -3. Minus x. So we get y greater or equal to -x minus 3. And that's our inequality. Let me put a 1 over 1 again. My intercept is -3. Now we'll go 1 up and 1 left, or 1 down and 1 right. Doesn't matter which one. As long as you know that when you connect, it gives you a negative slope, which in this case looks like, shoot. Let me change this to green. There. All right. So let's give this guy a name. Y is greater or equal to -x minus 3. Does 0, 0 work or don't work? Let's see. 0 is greater or equal to, well, 0 times -1 is just 0, and then -3. So that is true. The point 0, 0 worked, so we want to shade everything above the line, right? Because it's on the same side as 0, 0. So any point on that side above the green line, including the points on the line, will make that inequality true. So that's one. Second one, pick blue. X plus y less or equal to 3. And we get minus x. Uh-oh. I should have realized this earlier. It's okay. Y less or equal to -x plus 3. It's going to be interesting. So let me put a 1 over 1 here. So my y-intercept is 3, right here. And again, it's a negative slope. And we're going to go one up and one left, or one down, one right. Remember, as long as when we connect, we have a negative slope. So this one, what color am I using? Blue. It's going to be solid. And it's the same slope as the previous problem. Exactly same slope. It's the only difference is, so they're going to be parallel, right? They're going to be parallel. Now, if this was an equation, right, a system of equations, then the answer would be no solution because there are no points that they're sharing. But let's see what happens here. So now I'm going to take the point 0, 0 to decide if I'm going to shade like this above the blue line or below the blue line. So that's what I'm doing next. So let's pick the point 0, 0. Replace x and y with 0. So I get 0 less or equal to 3. Is 0 less or equal to 3? No, it's not. So I don't want to shade under the blue line, but I want to shade above the blue line. So there. Right? So notice that our solution is going to be, and I'll put it in red, this side here. Any point there satisfies both inequalities. So let's pick a point that's there. Let's pick this point right here. I guess you can see it. What is that? 3 and 3. First inequality, we got 3 plus 3 greater than negative 3, so that's so true. Second inequality, we get 3 plus 3. Uh-oh, what did I do wrong? I did something wrong. Hang on. Let me go back. Did I shade something? Sorry. Well, that's why you do your check. I did something wrong. Let me just go back. Let me go back to the green one. All right, so let me just check that one. I'm gonna go back. I'm gonna go back all the way back. X plus y is greater than negative 3 minus x. Y is greater or equal to negative x minus 3. Good. I use 0, 0. I get 0 greater than negative 3, so I want above the green line, including the points. And it looks like we're okay here. I gave it a name. Okay, so it looks like we're good. Second one, we did x plus y less than 3 minus x. We get y is less or equal to negative x plus 3. Good. So my y-intercept is 3. There we go. And it's also a negative slope. And so far so good. I'm going to do my check, and I forgot to do this, and I forgot to do that. Hang on a second. And this is my line y less or equal to negative x plus 3. Right, so now take the point 0, 0. Let me pick the point 0, 0. See if that's true. I get with 0 less or equal to negative 1 times 0 plus 3. 0 is less or equal to 3. That is true, by the way. Oh my god, that's where my mistake was. 0 is less or equal to, that's true. So in this case, because 0, 0 worked, I want to shade this way. So what's my solution here? My solution is this narrow area here. I'll put a big S here. This is my solution. Points in there. Okay, that's where my mistake was. Let's pick a point there. Let's pick 0, 0. Well, it's a point in that solution area, right? Let's see if it works for the first one. 0 plus 0 is greater than negative 3. That's true. The second one, 0 plus 0 is less or equal to 3. That's also true. So now I'm correct. All right. All right. Maybe I should do something. What do we have here? Critical thing. State one solution in this system. So first of all, the one thing I would do here is, first one's okay. Sorry. 2x minus 1. And this one I would rewrite it as y is greater or equal to negative x plus 10. That just makes it easier when I graph it. So you guys can graph that. Again, you can give me one solution. Write a system of inequality whose solution is the set of all points in quadrant 1, not including the axis. Ugh. Okay, so let me go back here. Think about what they're asking. They want something. They want not including the axis. So quadrant 1. The solution is every single point in here. So except not including the axis. So this would be a dashed line. Dash, 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 dash. I'll continue. So what is that line, first of all? Right, that is the y-axis, yeah? And we would say greater than 0. That would be the inequality, because if I were to graph this, right, 0, 0, well, I can't use 0, 0 because it's not, it's a point that's on the line and it's dashed, right? So it's right off the bat, we know that's not going to work. So let's take the test point 1, 1. If we take the test point 1, 1, and we replace y with 1, y 1 equals 0, we know that's true. So right off the bat, and let's just do this, I know anything above this line is my solution. Right? So I'm not done yet because I need another inequality. And my other inequality is going to be x greater than 0. So let me try. Sorry. Now, if you had x greater than 0, well, you would, on the x-axis, if you go to 0, you would do a dash line, right? Dash, 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 dash. And we want to see where we would shade. So obviously we want to shade here because it says that we want answers at all the points in quadrant 1. So let's pick a point here just to prove it. 2, 2. Well, if you pick the point 2, 2 and you replace x with 2, you get 2 greater than 0, which is true. So which means that I would shade this way. Right? So the system of inequalities that would have an answer that are all the points in quadrant 1 will be y greater than 0. That's my first inequality. And the second inequality would be x greater than 0. And the solution is this area right here, right? Every single point in quadrant 1. Okay, now I shall go have dinner.